Hello, in this video we're going to talk about Into Math 4th grade, Module 11, Lesson 6. And what we're going to work on in this video is using common numerators or denominators to compare two fractions that have different numerators and denominators. We actually did a first video for this lesson where we focused on the common denominator strategy. In this video, we're only going to focus on the common numerators. So if you're confused about the denominators, check out that video. If you need help with the numerators, here's the video for you. Now, both of these strategies, both common numerator and common denominator, build on the work that you did in lesson 3 and 4 about equivalent fractions. That's going to be the key to these lessons. So let's look at an example problem using a common numerator. Our problem here says Dorothy swims 2/5 of a kilometer, Duke swims 3/8 of a kilometer. Who swims farther? Use a common numerator to compare the fractions. So if you haven't yet tried this problem on your own, I'd really encourage you to pause the video, think it through on your own, maybe draw some pictures, use some manipulatives, some fraction tiles if that's helpful, just to get a feel for what's going on, see if you can work it through on your own, and then come back either to check your answer or if you need a little help. All right, hopefully you've thought a little bit about this problem. Now, what I always like to do when I'm comparing fractions, because that's what we're doing here, we're saying which fraction, 2/5 or 3/8, is larger. And so one strategy is to use common numerators, and that's what we're going to look at. But before we do that, I just want to get a picture of this. I want to look at what does 2/5 look like. Sorry. Changing my mind about what I'm going to do here. So 2/5, what does it look like? So we draw our rectangle, and then I need to cut that into 5 equal pieces, and I'll do my best to make them equal here. 1, 2, 3, 4, and 5. Not bad. Now I also need 3/8. Try to get my rectangle to be the same size here because I know when I'm comparing fractions, I must be comparing the same whole, which we are in the problem because we're talking about a kilometer, and the kilometer is the same either way. But I just want my picture to be pretty close. Now I need 1/8. Cut it in half, and then in quarters, then cut each of those quarters in half. Help me do this a little bit more effectively. I did my best again to make those the same size. They should be the same size, but I know when drawing it myself, it's sometimes difficult. Let's just make sure we have this correct. This one's supposed to be split into 5 equal pieces. 1, 2, 3, 4, 5. Yes. This one in 8 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. Good news. Now, I need to show 2/5. Well, 2/5 means I have 2 of the 5 pieces. So I'll shade that. Pretty good. And 3/8 means I have 3 of the 8 equal pieces. 1, 2, 3. I'll shade that. And as I look at the comparison here, again, I've done my best to make my two rectangles roughly the same size. I've done my best to make sure my pieces are cut into equivalent sizes. And now as I look at the two pictures, is this 2/5 more or less than the 3/8? It looks maybe like the 3/8 is bigger, but I know my picture is not perfect, and it certainly looks reasonably close. You know, I can't just look at it and be like, oh, well, it's clearly this one. No. So what I need is I need a way to use equivalent fractions so that I can directly compare. In the common denominator picture, what we did was we generated equivalent fractions so that each rectangle was cut into the same number of equal size pieces. That's using the denominator because the denominator tells me how many pieces is my whole cut into. In the common numerator strategy, we're going to say, well, it's okay if we have a different number of pieces. It's okay if my pieces are differently sized. I just want to have the same amount of pieces. And so I think about common multiples. And so here's another place where you can pause for a second and think about, I want to know, list all the multiples of 2 and all the multiples of 3 and find one that is common. So pause the video for a second. Think about what that common multiple would be. All right, so what I see for a common multiple here is that 2 times 3 is 6, and 3 times 2 is 6. So what I need to do is I need to cut my rectangle up into more pieces so that, let's start with this one over here on the right, I want, instead of having 3 pieces, I want to have 6. And so the easiest way to do that is to cut them in half. And then I can't just do that for the ones I have to do it for everything. So now what I've done is I've said, well, if I multiply the numerator by 2, taking it from 2 pieces to 6 pieces, then I also have to multiply the denominator by 2, saying, well, yes, you have 6 pieces, but altogether there are 16. So my equivalent fraction here, we're saying 3/8 is equivalent to 6/16. Now we do the same thing with the fifths, but now in order to make this common, I need the numerators to be the same. In order to make this a 6, I have to make 3 times as many pieces. So I go ahead and I cut into 3 times as many pieces. I have the same amount of my rectangle shaded, but it used to be 2 of the 5 pieces are shaded. Now it's 1, 2, 3, 4, 5, 6 of my now smaller pieces. So if we write this out in the same way as we did the other one, we have 2/5 times 3/3. Because in order to make sure that my fraction stays the same, I can't just cut the pieces I have into smaller chunks. I have to cut all of the pieces into smaller chunks. And that's going to be 6/15. And so now the question is, which one is bigger? This is my comparison. Now instead of comparing 2/5 against 3/8, now I'm comparing 6/15 to 6/16. So pause the video again for a second and think about which one is bigger, 6/15 or 6/16. So hopefully you've taken a second to think about that. And the way we can think about that is the denominator tells me how many pieces I've cut my whole into. Here I've cut the whole into 15 pieces. Here I've cut the whole into 16 pieces. And the more pieces you chop it into, the smaller each piece must be. So here I have 6 pieces, 1, 2, 3, 4, 5, 6, and each of those pieces is just slightly larger than each of the 6 pieces here. Now it's hard to tell from the picture because my rectangles are different shaped, but I know each one of these represents 1/16 of the whole, and 1/16 must be smaller than 1/15. So here I have 6 pieces, but each of those pieces is slightly larger. Here I have 6 pieces, but each of those pieces is slightly smaller. So 6/15 is bigger than 6/16. And this is a really important idea in terms of understanding fractions and how to compare them. So being able to go back and forth between common numerators and common denominators is a really powerful skill for us. All right, thanks for watching.